On June 13th, 2024, Microsoft made a decision that exposed how fragile trust had become around artificial intelligence inside Windows. 5 days before the first Copilot Plus PCs were supposed to reach customers, the company delayed the feature that defined the entire launch. It was called Recall, and its promise sounded almost magical. Windows would remember what had appeared on your screen so you could find it later. But the same sentence could be read another way. Windows would watch what appeared on your screen, preserve it, analyze it, and make it searchable. The backlash was immediate because Recall did not feel like another app. It felt like the operating system itself had learned to observe. Security researchers examined the early design and warned that a searchable history of screen activity could become a map of a person's digital life. Passwords, medical portals, private messages, financial records, confidential documents, and moments never intended to become a permanent could pass through that map. Microsoft pulled Recall from the launch, rebuilt major parts of its security architecture, and eventually returned it as an opt-in preview. That retreat seemed to settle the argument. Users had controls. Snapshots stayed local. The feature could be removed. The crisis was over, except the deeper question never disappeared. What happens when artificial intelligence stops being a program you open and becomes a permanent layer between you, your hardware, and everything you do? By August 2026, Microsoft still had not announced an operating system called Windows 12. Its public roadmap remained focused on Windows 11. Official release pages described Windows 11 version 25.8.2, a hardware-specific 26.8.1 release, and experimental work connected to 26.8.2. There was no verified Windows 12 kernel, no documented neural telemetry channel immune to every user control, and no proof of the secret pipeline described in rumors. But dismissing the entire concern because the name is wrong would miss what has actually changed. The architecture people fear is not waiting for a dramatic Windows 12 launch. Pieces of it are already being assembled inside Windows 11. They do not form one hidden surveillance switch. They form something more complicated, overlapping systems with different settings, permissions, purposes, and escape routes. Some can be disabled, some can be removed, some can only be reduced, some operate locally. Others depend on Microsoft's cloud. And because they are separated across Windows, Copilot, Edge, Microsoft accounts, connected experiences, diagnostic services, and AI components, there is no single lever that turns all observation off. That is the real investigation. To understand it, the first distinction is essential. An NPU is not a transmitter. Microsoft's Copilot Plus PC standard made that silicon central to Windows by requiring NPUs capable of more than 40 trillion operations per second. Windows ML then gave developers a shared framework for running models across NPUs, GPUs, and CPUs, with hardware execution providers managed through Windows. That is a major platform change, but it is not evidence that the kernel is secretly uploading behavior. In fact, local inference can improve privacy. A document can be summarized, an image enhanced, or speech translated without leaving the device. Yet local AI also changes the economics of observation. Before, NPUs, continuously analyzing the screen, microphone files, or application state, could consume noticeable power and computing resources. With dedicated silicon, that analysis can happen quietly, persistently, and cheaply enough to become part of the operating system's normal behavior. The NPU does not need to steal data to become consequential. It makes continuous interpretation practical. That is why Recall mattered so much. It transformed ordinary screen activity into structured memory. The feature periodically captures snapshots when the content on the display changes, then analyzes text and images so a user can search past activity with natural language. Microsoft's revised design stores those snapshots locally, crypts them, and protects keys with the Trusted Platform module. Access is tied to Windows Hello, while sensitive operations occur inside virtualization-based security enclaves isolated from ordinary applications and even from important parts of the system. On managed commercial devices, Recall is removed by default unless an administrator allows it, and administrators still cannot force users to begin saving snapshots. On personal Copilot Plus PCs, users must opt in. They can pause collection, delete stored material, filter apps and supported websites, limit retention, or remove the optional component. Those details directly contradict the claim that Recall is an immutable surveillance pipeline that cannot be disabled, but they do not eliminate every concern. Recall's own architecture reveals how much context an AI operating system can collect without sending a screenshot to the cloud. Its snapshot store can include images, timestamps, application information, title bar text, launch references, and measurements, such as how long an app remained active. Its semantic index converts visible content into vectors, numerical representations that allow the system to retrieve meaning rather than merely match exact words. That index may remain local, but it still becomes a concentrated record of behavior. A local archive is not automatically harmless. It can be exposed through malware, physical access, stolen credentials, software flaws, unsafe exports, or a user who unlocks it while malicious code waits nearby. The existence of those defenses proves two things at once. It proves Microsoft recognized that an AI memory of screen activity is unusually sensitive, and it proves that the data has value high enough to justify building an elaborate protected system around it. This is where the word telemetry begins to blur the investigation. Traditional Windows telemetry usually means diagnostic events sent to Microsoft to explain hardware configuration, software reliability, crashes, update failures, security conditions, and feature performance. Microsoft separates that data into required and optional categories. Required diagnostic data is described as the minimum needed to keep Windows secure, reliable, compatible, and functioning normally. Optional diagnostic data can include deeper device details, application activity, enhanced error reports, browsing information in some circumstances, and memory captured during a crash. Users can turn optional Windows diagnostic data off. They cannot normally reduce a consumer Windows installation below the required level through the standard privacy interface. Enterprise and Education editions provide more administrative controls, but even there, disabling one category does not necessarily disable every connected service. Windows Update, Activation, Certificate Validation, Microsoft Defender, error reporting, cloud search, account synchronization, the store, Edge, Copilot, and individual applications may use separate channels. A registry value can alter a known policy. It cannot automatically govern every Microsoft application, web service, account feature, driver, optional component, or future update. Group policy is more powerful, but it is still a collection of documented controls rather than a universal command that means never analyze or transmit anything about this user. The privacy setting for Windows diagnostics is not the same as the privacy setting inside Edge. Copilot activity history is not the same as recall snapshots. Recall snapshots are not the same as Windows search indexing. Connected experiences inside Microsoft 365 are not the same as Windows telemetry, even when all of them appear on the same computer and belong to the same company. A user can disable one stream and leave several others untouched without realizing it. That fragmented control surface creates the impression of an unstoppable system because there is no single place where its entire behavior is visible. Even Microsoft's Diagnostic Data Viewer only addresses diagnostic data that the supported services expose through that framework. It does not function as an all-seeing network monitor for every application or cloud interaction. The deeper change is therefore not that one secret kernel service has defeated every registry edit. It is that the boundary of the operating system has expanded. Windows once mediated files, Windows, memory, devices, user accounts, and network connections. The emerging AI layer also mediates meaning. It recognizes what is on the screen, interprets natural language requests, builds semantic indexes, suggests actions, generates text, and routes tasks between local models and cloud services. When software begins interpreting meaning, the distinction between technical telemetry and personal context becomes much harder to maintain. A hardware event may reveal nothing sensitive. A snapshot of a medical portal may reveal almost everything. A semantic vector may not resemble the original sentence, yet it can still preserve enough meaning to retrieve that sentence later. AI does not need a perfect copy of private information to infer something valuable from it. It can work from patterns, associations, timing, categories, and repeated behavior. That possibility explains why the phrase AI telemetry feels more threatening than the older language of diagnostics. People imagine a system that does not merely report that an application crashed, but learns which applications matter, what content attracts attention, how tasks unfold, and what a user is likely to do next. There is no public proof that Windows currently combines all of that information into a covert behavioral profile inside the kernel. But the technical ability to generate richer context is expanding faster than the average user's ability to understand every control. Microsoft's built-in AI components illustrate the direction. Windows now supports on-device language and vision models, semantic search, image processing, text recognition, writing assistance, live captions, and contextual actions. The shared runtime can be updated through Windows Update, while applications can use system-managed execution providers rather than shipping a separate AI stack. From a developer's perspective, this is efficient. From a privacy perspective, it creates a permanent platform layer whose capabilities can evolve without the user reinstalling an entirely new operating system. That is likely why so many rumors attach the name Windows 12 to changes that are arriving incrementally. People expect a visible border between generations. Windows 11 ends, Windows 12 begins, and the dangerous feature crosses with it. Microsoft's current servicing model is less theatrical. Capabilities can arrive through monthly updates, feature enablement packages, store-delivered components, web experiences, application updates, driver packages, and cloud-side changes. The desktop may look almost identical while the underlying relationship between software and data changes substantially. A system does not need a new name to become a different kind of system. This also explains why the kernel claim is so persuasive even when it is technically unsupported. The kernel is imagined as the deepest, least removable layer of the machine. If telemetry lives there, ordinary users cannot uninstall it like an app. But most modern data collection does not need to be literally hard-coded into the kernel to be difficult to escape. A web-based component can change on Microsoft servers. An account can synchronize settings across devices. An application can maintain its own diagnostic channel. A feature can depend on an endpoint that also supports security or reliability, making blunt blocking produce collateral damage. The practical result can feel immutable, even when the implementation is distributed across user mode, system services, cloud infrastructure, and hardware drivers. Blocking every Microsoft endpoint is not the same as achieving privacy. It can break activation, updates, malware intelligence, certificates, the store, time synchronization, account authentication, fonts, licensing, and other functions users expect the operating system to perform. Allowing everything is not the same as informed consent either. Between those extremes lies a complex configuration problem that Microsoft has not reduced to one understandable decision. Recall demonstrates both the promise and danger of local processing. Microsoft states that snapshots are saved and analyzed on the device, are not sent to Microsoft, and are not shared with other Windows users. That design avoids the most obvious nightmare: a searchable copy of the screen continuously uploaded to a corporate server. Yet the feature still changes what exists on the device. Without recall, many screen moments disappear when the window closes. With recall, those moments can become durable indexed artifacts. Encryption protects the archive while the system is locked or the keys remain inaccessible. But once the authorized user opens recall, selected information must be decrypted and displayed. Every useful security system contains a moment when protected data becomes usable, and that moment becomes part of the attack surface. The same principle applies to AI features that promise context. An assistant cannot summarize a document it is never allowed to read. It cannot help complete a task without receiving some representation of that task. It cannot search memories that were never recorded or indexed. The question is where it is processed, how long it persists, who can access it, what secondary information is generated, and whether refusal remains meaningful. The control must be visible. The default must not pressure the user into acceptance. Disabling the feature must stop the relevant processing. Stored data must be deletable. The operating system must not silently re-enable the choice after an update. Core security functions must remain available, and the user must be able to verify the result without becoming a reverse engineer. Recall Now meets more of those conditions than its original launch design appeared to meet. It is opt-in, removable, locally processed, and surrounded by controls. But Windows as a whole does not offer a single answer to the larger question, because Windows as a whole no longer has one privacy model. Consider Copilot. When a user submits a prompt to a cloud-connected assistant, the text must leave the local machine to be processed unless a local model handles the request. Microsoft provides account controls for Copilot activity history, and different rules apply to personal, commercial, and Microsoft 365 environments. In some enterprise contexts, prompts and responses are logged and can be available through organizational audit and compliance tools. In personal contexts, activity can be managed through the Microsoft Privacy Dashboard, while optional diagnostic settings exist inside the Copilot application. This is not hidden kernel telemetry. It is a service relationship created when the user chooses to invoke a cloud assistant. But Microsoft increasingly places that assistant close to the center of Windows, making the distinction between optional service and operating system behavior less obvious. The same ambiguity appears in connected experiences. A feature may be technically optional, yet disabling it may remove capabilities people consider fundamental to the product they purchased. Microsoft 365. Copilot depends on connected experiences that analyze content. Turn those experiences off, and the Copilot functions stop working. The user retains a choice, but the choice is bundled: accept the data path or surrender the feature. That is not the same as collection without consent. It is also not the same as full autonomy. Autonomy means more than having a switch. It means having realistic alternatives. A person who can refuse only by losing search quality, synchronization, AI assistance, cloud backup, or compatibility may technically control the setting while still being pushed toward acceptance. This pressure becomes stronger as developers design applications around shared Windows AI services. Once the NPU, runtime, model packages, and semantic interfaces become standard assumptions, opting out may gradually feel like running the operating system in a degraded mode. Nothing in current documentation proves Microsoft plans to make that degradation punitive. But platform history shows how defaults become dependencies. Internet Explorer began as an application and became intertwined with Windows. A Microsoft account began as one sign-in option and became increasingly central to setup, synchronization, backup, store access, and subscription services. Search evolved from local file lookup into a mixture of device indexing, web results, recommendations, and cloud-connected experiences. AI can follow the same path without a single dramatic announcement. This is the second reason the Windows 12 rumor survives. It compresses a slow architectural transition into a simple villain. A secret operating system with an undeletable surveillance core. Reality is less cinematic and more difficult to resist because every individual component can be defended as useful. Diagnostic events improve reliability. Cloud prompts provide larger models. Local models reduce latency. Semantic indexes improve search. Snapshots recover forgotten work. Account synchronization restores settings. Usage measurements reveal bugs. Personalization makes suggestions more relevant. Security telemetry detects threats. Each justification can be valid. The danger emerges from accumulation. When many legitimate systems observe different fragments of activity, the combined environment may know far more than any single privacy page suggests. Whether Microsoft actually combines those fragments depends on product boundaries, legal commitments, technical separation, account state, regional rules, and user settings. Those conditions are difficult for ordinary users to audit. The most important word in the original claim is therefore not kernel, it is cannot. What exactly cannot be disabled? Required. Windows diagnostic data cannot normally be turned completely off through consumer settings. Optional diagnostic data can be turned off. Recall snapshot saving can be left off, paused, or disabled. Recall can be removed as an optional component. Copilot can be avoided or disabled in several contexts, though the exact controls vary by product and edition. Connected experiences can be disabled, but doing so removes associated features. Some services can be restricted through group policy on supported editions. Some endpoints can be blocked, but that can impair unrelated functions. Some application telemetry uses controls separate from Windows. The honest answer is not that users have no power. It is that their power is fragmented, edition-dependent, update-dependent, and difficult to verify as a complete state. Registry scripts often fail because they promise something the architecture cannot guarantee. A debloating tool may remove packages visible today, but cannot predict what a future cumulative update will restore or replace. A host's file may block known domains but miss content delivery networks, changing endpoints, encrypted DNS, application-specific connections, or services sharing infrastructure. Disabling a service may stop one collector and break another component that depends on it. Renaming system files can trigger repair mechanisms or create security vulnerabilities. Running an unsupported configuration may also prevent updates that close real exploits. The pursuit of privacy can accidentally weaken security, and that trade-off is rarely explained in viral guides. A more credible defense begins by separating goals. Someone who wants to stop screen history should verify that recall is off or removed. Someone who wants to reduce Microsoft diagnostics should disable optional diagnostic data, personalized experiences, and unnecessary feedback settings. Someone who wants to prevent cloud AI processing should avoid submitting sensitive content to cloud assistants and review connected experience settings. Someone managing an organization should use documented policies, edition-appropriate controls, network monitoring, application allow lists, data loss prevention, and contractual protections. Someone requiring absolute separation should not rely on a consumer operating system connected to the internet. An air-gapped or tightly controlled environment solves a different class of problem, but it sacrifices convenience, cloud services, rapid collaboration, and sometimes maintainability. Even then, the machine still processes local data. Privacy is not the absence of computation. It is control over exposure. This brings the investigation back to Windows 12. As of August 2026, the name remains speculation rather than an announced product. Microsoft's official materials still describe the active client platform as Windows 11, including the releases and experimental branches receiving current development work. No public technical documentation supports the allegation that Microsoft has hard-coded an AI behavioral harvesting pipeline into a Windows 12 kernel. No verified evidence shows NPU hooks secretly transmitting real-time user behavior beyond all registry, policy, feature, and network controls. Presenting that claim as fact would replace a real privacy debate with an invented mechanism. But the absence of that mechanism does not restore the old world. The computer is becoming capable of understanding far more of what passes through it. The operating system can support models that interpret text, images, speech, application state, and user intent. It can preserve context, convert it into searchable representations, and expose AI services to applications through a shared platform. Those capabilities can remain local and private. They can also be paired with diagnostics, accounts, cloud inference, personalization, and commercial incentives. The outcome depends on defaults, boundaries, transparency, and enforceable control. Microsoft's stated position is that required diagnostics protect reliability and security, optional data can be controlled, and on-device AI can keep sensitive information local. Those claims describe genuine design choices. Critics focus on what those statements do not resolve. Required collection remains required, proprietary code limits independent visibility, settings are distributed, features evolve after purchase, and users often cannot inspect the exact behavior of every component. Both sides are describing different layers of the same system. Microsoft describes individual data flows and their protections. Users experience the total machine. The total machine may contain dozens of lawful, documented, separately controlled channels that collectively feel like one observer. This is why transparency cannot end with a privacy statement. A trustworthy AI operating system needs an intelligible control plane showing which models are running, what sensors or content they access, whether processing is local or remote, what data is retained, what leaves the device, which account receives it, and which application initiated the request. It needs logs understandable to normal users, not only administrators. It needs stable off switches that survive updates. It needs per-feature permissions rather than broad consent. It needs clear separation between security diagnostics, product improvement, personalization, advertising, and model development. Most importantly, it needs a mode in which declining AI observation does not turn the operating system into an unsupported or deliberately inferior product. That standard is higher than proving a secret telemetry kernel exists. It asks whether the user remains the principal authority over the machine. The answer today is mixed. Users can stop many AI features, but not every required diagnostic exchange. They can keep recall off, but they must understand that recall is only one layer. They can disable optional data, but separate applications may retain separate controls. They can use local AI, but local processing may still create sensitive artifacts. They can block network traffic, but blunt blocking can damage security and functionality. They can choose another operating system, but every modern platform carries its own trade-offs, and hardware ecosystems increasingly assume cloud accounts and AI services. The danger is not a single unstoppable pipeline. The danger is normalization. Once continuous interpretation becomes ordinary, each new feature begins from a different assumption about what a computer should know. Yesterday, the operating system needed to know which file you opened. Today, it may understand what appeared inside the file. Tomorrow, it may anticipate why you opened it, what you intend to do next, and which service should help. And that progression can produce extraordinary accessibility, productivity, search, translation, creativity, and security. It can also create the most intimate computing environment ever deployed at mass scale. The difference between those futures will not be determined by the number printed after the word Windows. It will be determined by architecture. Does the model run locally? Can the feature operate without an account? Is data minimized before transmission? Can the user inspect the record? Can the record be deleted? Can the component be removed? Are controls enforced below the application that benefits from ignoring them? Does refusal survive an update? Can independent researchers test the claims? And when Microsoft changes the system, does consent have to be earned again? Those are the questions hidden beneath the Windows 12 rumor. They are less dramatic than a secret kernel implant, but they are more urgent because they describe decisions being made now. The moment that triggered this investigation was not the discovery of an invisible Windows 12 data channel. It was Microsoft delaying recall days before launch because the public recognized that an operating system with memory creates a new category of risk. The redesigned feature answered many of the immediate security criticisms. It did not answer the larger political question of who should control an intelligent computer's perception. That question will return with every semantic index, every local model, every cloud assistant, every contextual action, and every diagnostic event connected to those systems. By the time a product officially called Windows 12 arrives, the most important choices may already have been normalized through Windows 11 updates. There may never be one moment when the surveillance switch is installed. There may only be a sequence of useful features, each asking for one more piece of context, until the machine's understanding becomes difficult to separate from the user's life. The secret is not that Windows 12 already contains an undeletable AI telemetry pipeline. The secret is that the future of Windows does not require one. A distributed architecture of local models, required diagnostics, cloud services, account synchronization, semantic memory, application telemetry, and updatable components can produce the same feeling without any single hidden mechanism. The real test of the next Windows will not be how intelligent it becomes. It will be whether intelligence remains a tool the user commands rather than an environment the user cannot escape. The future of privacy will be decided not by whether Windows can see, but by whether the user can still say no